I gotta subtract 3x, so I'll have 2y equals negative 3x minus 4. I now have to divide everything by 2. Get y by itself, so y is going to be equal to negative 3 over 2x minus 2. So now when I graph this line, there's the y-intercept down here on negative 2. I'm going to go down 3, right 2, down 3, and right 2. Or up 3 and left 2. There's my line. So, which quadrants contain this line? Which quadrants do does the line go through?
2, 3, and 4.
2, 3, and 4. Okay, so it's going to be J. Because it doesn't pass through quadrant 1, does it? Questions on that? All right, number 3. The point 4, 5 is shown right there. Which of the following is another point on the line to the point 4 and 5 with a slope of negative 4/3? So remember, this is rise over run. So you can either look at this as negative 4 over positive 3 or positive 4 over negative 3. So if I were to go down 4 and right 3, I would land on point A. If I went up 4 and left 3, I don't land on any of the other points that are already there. So what's the obvious answer? Point A, which is 7, 1. Questions? Okay, now we're going to look at some basic right triangle trig. So obviously it's called right triangle trig because it has to be a right triangle to use sine, cosine, or tangent. So in a right triangle, the longest side, the side opposite of the right angle, is always going to be what we call the hypotenuse. That's always going to be the longest side. Now, there's always what we call a reference angle. Okay, the reference angle will either be this acute angle or this acute angle. In this case, the reference angle is this one down here. So the side opposite of that angle is obviously over here, right? This would be opposite. And then the side next to the angle, that's not the hypotenuse, we call the adjacent side. Now again, unless you have these memorized, the 3 primary trig ratios are sine, cosine, and tangent. The sine ratio, we take the length of the opposite side and divide it by the length of the hypotenuse. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Okay? And then they have the inverse functions, which is where we just flip what we just did. So the inverse sine is opposite over hypotenuse. Inverse cosine and inverse tangent. Okay? So, how do we use that to solve problems? Look at problem number 4. It says, which of the following equations is a valid equation for the side measurement of y in inches side measurement X in inches and the angle measurement of W in the rectangle shown below. Well, we know in rectangles, all four corners are right angles, right? So what kind of a triangle have we created right here?
Right?
The right triangle. So do our trig ratios work in this triangle? Yes or no? They do, right? Okay? So, what's our reference angle? Is angle W. So what would X be? Opposite, adjacent, or hypotenuse?
Opposite.
That would be opposite, good. What would side Y be?
Adjacent.
Would be adjacent. So if you go back up to your trig ratios, which trig ratio uses opposite and adjacent? Sine, cosine, or tangent?
Tangent.
Tangent. So remember, tangent of W is gonna be equal to opposite over adjacent, which is which one over here? X over Y, right? Because X is opposite, Y is adjacent. So tangent of W equals X over Y, which is gonna be H. Question. Okay, number 5. The hypotenuse of triangle ABC is 20 inches long, so which side would be the hypotenuse here? Which side is the hypotenuse?
A?
Which side, not angle, which side? Right, we named the sides AB, BC, and AC. Which side would be the hypotenuse?
AC?
AC. So we know this is 20 inches. Okay? It says that the sine of angle C, so this is my reference angle, angle C, is 4 over 5. They want us to identify what is the length of AB. So AB is unknown X, right? Okay, well, if I were to take this and this, right, that would be opposite and hypotenuse. Which would that be, sine? Yes or no?
Yes.
Yeah, so I know that sine of C equals X over 20. Because this is opposite. This is hypotenuse. That's what it says. Okay. Well, if the sine of angle C is 4/5, then can I just set 4 over 5 equal to X over 20 and solve this? So 5 goes into 20 4 times. 4 times 4 is what? 16. Okay, so X would be equal to 16 inches. Now, the question is, what is the length of side AB? And we're gonna go with 16 inches. Right? That makes sense? Okay, number 6. Okay, we're using the same triangle, looks like. Says if the sine of A is 3 over 7, the cosine of A is, oh no, we can just use the numbers that they give us. So if the sine of A is 3 over 7, and the cosine of A is 4 over 7, what would be the tangent of A? Well, remember, sine of A is opposite cosine of A is adjacent over hypotenuse. What do we know those numbers are? 3/7, right? And 4/7. And then what's tangent? Opposite over adjacent, right? So is it opposite 3 and adjacent 4? So tangent of A would be 3, 4. Number 7. A right triangle has side measures in the same unit of length as shown below. For any such triangle, okay, and they're using Greek letters here for the angles. So the sine of that Greek letter times the cosine of that Greek letter is equivalent to what? Okay, so how we gonna solve this? Well, let's look at what the sine of this angle is right here. So sine, remember, is what? What's our ratio for sine? Opposite over what? Hypotenuse. What's the opposite side of this angle? Which side of x is opposite? Good. This would be x. What's the hypotenuse in this triangle? Isn't it y? So the sine of this angle here is x over y. Okay, what is cosine of this angle? Now we're changing our angles, aren't we? So now we're looking at this as our reference angle. So now we know that cosine is adjacent over hypotenuse. What's the adjacent sine to this?
X,
X would be adjacent. What's the hypotenuse still?
Y.
Y. So now they're asking us to multiply those two together, right? That's what this means. We're multiplying those, we're taking x over y times x over y, which is gonna give us what? X squared on top, y squared on the bottom. So what's my solution? X squared over y squared. Questions? Okay, last three problems. All right, problem number 8, we have a cone. Now, in a cone, if we take a cross section of a cone, notice we get a right triangle. If we take the vertex of the cone, that if we were to like put a straight line through the tip of the cone to the center of the circular base, right? That would give us a leg. The radius of the circular base would give us the other side that forms the right angle, and then the outside lateral distance along the outside of the cone would give us the hypotenuse. So here it tells us that the radius, okay, is 5. So that's that measurement right there. It tells us that the slant height of the cone is 8, which is that distance. It says solving which of the following equations, given this is my reference angle of the angle formed by the slant height of the cone and the radius. So which of those, so if this is 5 would be what? Adjacent, right? What would 8 be? Would 8 be opposite or hypotenuse?
Hypotenuse.
Would be hypotenuse. So which trig ratio uses or adjacent and hypotenuse?
Cosine.
So cosine of theta versus that angle equals 5 over 8, which is h. Okay, number 9. For the triangle below, what is the value of the cosine of x? So x is the reference angle. Okay, remember, cosine is gonna be what ratio?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So in this case, what would be the adjacent side to angle x?
8,
8. What would be the hypotenuse?
17.
So 8 over 17 is 8. Final question. This is kind of an application problem because we have a ladder that has been leaned against the house at a 60-degree angle, so that's my reference angle. We know that the ladder is 4.6 meters away from the base of the house. Which one of the following expressions would solve for the length of the ladder? So we're trying to solve